Hello everyone, my name is Prashant Prasanna Kumar and today I'll be discussing the mathematics solutions from GATE 2021 Aerospace paper. So let's begin. Here's the first question. Consider the differential equation d square y by dx square plus 8 dy by dx plus 16y equals 0 and the boundary conditions y of 0 equals 1 and dy by dx of 0 equals 0. The solution to this equation is, so let's start by writing the characteristic equation. So it comes to d square plus 8d plus 16 of y equals 0. The roots of this quadratic equation are minus 4 and minus 4. So the complementary function, we get that as y is equal to, since the roots are repeated, we go for c1 plus c2x into e raised to this minus 4. So e raised to minus 4x. Now to apply the boundary conditions, since there is dy by dx also, differentiate this and keep it ready. So by differentiating we get dy by dx is equal to c1 plus c2x into minus 4 e raised to minus 4x plus c2 into e raised to minus 4x. Now substitute the boundary conditions. At x equal to 0, we will get y of 0 as 1. So 1 is equal to c1 plus 0 into e raised to 0. So we get c1 as 1. Substituting the boundary condition here, we get dy by, we get dy by dx of 0 as 0. So 0 is equal to c1 plus 0 into minus 4 plus c2 into e raised to 0 is again 1. So this gives us c2 is equal to 4c1, and since c1 is 1, we get c2 as 4. These are the two values, 4 and 1. So c1 is 1 and c2 is 4, and we check the options now. So option D matches over here, 1 plus 4x into e raised to minus 4x. So next question. U of x comma y is governed by the following equation: dou square u by dou x square minus 4 dou square u by dou x dou y plus 6 dou square u by dou y square equals x plus 2y. The nature of this equation is, so the standard form is a dou square u by dou x square plus b dou square u by dou x dou y plus c dou square u by dou y square plus d dou u by dou x plus e dou u by dou y plus f is equal to 0. So comparing the standard form with the given equation, we get a as 1, b as minus 4, and c as 6. D and D don't matter over here. Now we find the determinant, that is b square minus 4ac. This thing comes to minus 4 square is 16, minus 4 into a is 1, into c is 6. The final value comes to minus 10, which is negative. And since this determinant is negative, the function is elliptic. So the correct option is B. Moving on to the next question. Consider the velocity field V equals 2x plus 3y into I cap plus 3y plus 3x plus 2y into j cap. The field V is divergence free and curl free but not divergence free, and combinations of those. So we have to find the divergence and curl and see if it comes to 0. If it comes to 0, it's free from that corresponding quantity. So let's start with the divergence. So divergence of vector V is equal to, just apply the standard formula, dou by dou x of the x component, which is 2x plus 3y, plus dou by dou y of the y component, which is 3x plus 2y. This thing comes to 2 plus 2, which is 4, which is not equal to 0. So since divergence is not 0, this has divergence. Next, curl of V. Use the standard formula. I dou by dou x, and the x component is 2x plus 3y, j dou by dou y, the y component is 3x plus 2y, and k dou by dou z, the k component is 0. So this thing will come to I cap. Derivative is 0 here, derivative is again 0 here, minus j cap. Dou by dou x of 0 is again 0, minus dou by dou z of 2x plus 3y is again 0, plus k cap. Dou by dou x of 3x plus 2y comes to 3, minus dou by dou y of 2x plus 3y, that also comes to 3. So 0 minus 0, 0, this is also 0, 3 minus 3, 0, so we get 0 vector. So this is curl free. So this is curl free but not divergence free. So the correct option is option B, curl free but not divergence free. Moving on to the next question. So this is a NET question. So let's solve this. The limit as x tends to 0 of 1 by sin x minus 1 by x. First, directly substitute the limit to get 1 by sin 0 is again 0, minus 1 by x is 0, so 0. This comes to infinity minus infinity form. So start by cross multiplying this, multiplying the terms. So we get limit as x tends to 0 of x minus sin x all divided by x sin x. This, when we substitute x equal to 0 here, we get 0 minus 0 by 0. So this is 0 by 0 form. So apply LH rule. So after applying LH rule once, we are going to get limit as x tends to 0. Derivative of x minus sin x is 1 minus cos x. And the derivative of the denominator is x cos x plus sin x. This is, let's substitute the x equal to 0 again over here. So we get 1 minus cos x, it comes to 1 minus 1, which is again 0. And the denominator comes to 0 plus 0 again. So again 0 by 0 form. So we apply LH rule again. This time we are going to get limit as x tends to 0. So derivative of 1 minus cos x is sin x all divided by the derivative of the denominator we'll get as minus x sin x plus of cos x plus cos x. So this will give us the value after substituting the limit as sin 0 in the numerator, which gives us 0. the denominator we get 0 plus 1 plus 1. So the final value is 0. So the correct answer for this is 0. Moving on to the next question. Given that zeta is the unit circle in the counterclockwise direction with its center at origin, the uh, integral of z cube by 4z minus I dz is equal to what? So we have this function f of z. We have to see if the poles of this function they lie inside the given curve or not. So since zeta is the unit circle, um, let's start by drawing that. This is unit circle mod z is equal to 1. Now the poles of this f of z. Let's first write f of z first. F of z is z cube by 4z minus I. So for poles, we are going to get 4z minus I is equal to 0. That is the denominator is equal to 0. This gives us z is equal to I by 4. Z is equal to I by 4 lies somewhere over here. So this point, it lies inside the given curve. So to evaluate the integral, we use a residue theorem. From here, we get the value of the integral. Let's call it I. It has 2 pi I into sum of residues. So we get 2 pi I into limit as z tends to I by 4. We multiply it with z minus I by 4 also to cancel out the pole, and f of z. F of z is z cube by 4z minus I. So if we take 4 common from the denominator, the z minus I by 4 will cancel out, and substituting the z equal to I by 4, we get this 2 pi I into I by 4, the, one second, I by 4, the whole cube, whole divided by 4. So simplifying this further, we get 2 pi I into I cube gives us I raised to 4, which is 1. So divided by 4 into 4 cube. Cancelling 1 to over here, we are going to get pi divided by 128. So the final value comes to 0.024. This is the right answer. Let's move on to the next question. Which of the following statements is or are true about the function defined as f of x equals e raised to minus x mod of cos x for x greater than 0? Differentiable at x equal to pi by 2, differentiable at x equal to pi, x equal to 3 pi by 2, and continuous at x equal to 2 pi. These are the 4 options. This is an MSQ, so we have to evaluate all the 4 options and see which of these are correct. There can be multiple options which are correct. So let's first rewrite f of x. F of x is equal to, we'll write this as e raised to minus x cos x for cos x greater than 0, and e raised to minus x cos x, minus e raised to minus x cos x for cos x less than 0. Now we'll evaluate option D. So at x equal to 2 pi, for option D, at x equal to 2 pi, cos of x, which is cos of 2 pi, it comes to cos 2 pi is 1. And since 1 is greater than 0, we will be applying this expression. And since there is only one expression for this, it is going to be continuous at x equal to 2 pi. Hence, this option is correct. Let's move on to the next options. To check differentiability, we need to first differentiate this function. So we will get f dash of x is equal to minus e raised to minus x cos x minus e raised to minus x sin x. This is for cos x greater than 0, and e raised to minus x cos x plus e raised to minus x sin x for cos x less than 0. This is I have gotten this by differentiating this, differentiating f of x. So now to evaluate the different options, we'll check the value of cos x at each of those points. So let me just move this to a new slide. Fine. Now option A was at x equal to pi by 2. At x equal to pi by 2, we are going to get cos of x as cos pi by 2, which is equal to 0. So at 0, we have to evaluate both the left hand and right hand derivatives. So the left hand derivative, it comes to, the left hand will be this expression. This is left, this is right. So at the left hand derivative, we substitute cos pi by x equal to pi by 2. So we are going to get e raised to minus pi by 2. So cos pi by 2 is 0 plus e raised to minus pi by 2 sin pi by 2 is 1. It comes to e raised to minus pi by 2. Then the right hand derivative, we get it as the negative of this only. So it will come to minus e raised to minus pi by 2. So these are not equal. Hence, not the derivative does not exist at x equal to pi by 2. Hence, the function f dash of the function f of x is not differentiable at x equal to pi by 2. Next, we go for x equal to pi. At x equal to pi, we have cos pi is equal to minus 1, and since minus 1 is less than 0, we'll be applying only the left expression. Since there is only one expression again, it is differentiable at x equal to pi. So at x equal to pi, it is differentiable, it is true. Next, to evaluate option C, at x equal to 3 pi by 2, we get cos of 3 pi by 2 is equal to 0. Then we evaluate left hand derivative, it comes to It is over here. E raised to minus 3 pi by 2 into cos 3 pi by 2, this will come to 0. What will remain is this, e raised to minus 3 pi by 2, and the right hand derivative will come to minus e raised to minus 3 pi by 2, since the expressions are just the negative of each other. Again, the left hand and right hand derivatives are not equal. Hence, at x equal to 3 pi by 2 also, the function is not differentiable. So this statement is also false. So option B and option D, they are correct. So since this is an MSQ, option B and option D, uh, they both form the right answer. Moving on to the next question. The ratio of the product of eigenvalues to the sum of the eigenvalues of the given matrix 3, 1, 2, 2 minus 3 minus 1, 1, 2, 1 is dash. To find the product of eigenvalues, we can take the determinant also. So we have to find product divided by sum of eigenvalues. The product of eigenvalues is given by the determinant, and the sum of eigenvalues is given by the trace of the matrix. So determinant of the matrix by trace of the matrix, if we evaluate, we find the answer. To find the determinant, we are going to get 3, 1, 2, 2 minus 3 minus 1, 1, 2, 1. And to find the trace, we take the sum of the diagonal elements. So 3 plus minus 3 plus 1. So the denominator, it comes to plus 1. We can skip writing that. So evaluating the determinant, we'll be getting 3 into minus 3 plus 2 minus 1 into 2 plus 1 plus of 2 into 4 plus 3. So the final value we are going to get is minus 3 plus 2 is minus 1. Minus 1 into 3 is minus 3. 2 plus 1 is 3 into minus 1 is again minus 3. 4 plus 3 is 7. 2 is 14. So the final answer we get is 8. The correct answer is 8. Moving on to the next question. The definite integral of x squared dx from 1 to 5 is evaluated using 4 equal intervals by 2 methods. First by trapezoidal rule and then by Simpson's 1/3 rule. The absolute value of the difference between the two calculations is. So let's start by finding out the step size. Since there are 4 equal intervals, we are going to get the step size as h is equal to the upper value of the upper limit minus the lower limit divided by the number of intervals. 5 minus 1 by 4, the step size is 1. Then let's make a table of values x, y. So y value is x square. So we are going to start from x equal to 1, then 2, 3, 4, and 5. Then the y value of y equal to x square is 1, 4, 9, 16, 25. Just put this in a table. Now we'll evaluate the integral by trapezoidal rule first. So let's denote that by it. That's going to come to by the formula h by 2 into the sum of the first and last values. So 1 plus 25 plus 2 times the sum of the remaining values, 4 plus 9 plus 16. It's the value of h is 1, which is half, and simplifying, we are going to get the final value as 42. Next, find the same integral by Simpson's method, by Simpson's one-third rule. Since it's one-third, it's h by 3 here. Then we find the sum of first and last values. Then 4 times the sum of the even values. So 4 times the sum of the odd values, sorry. So that is 4 plus 16. This thing starts from y0 to y5. Sorry, not y5, it's y4. So, and 2 times the remaining value. That is the even values, which is 9. So, finally evaluating, we get this value as 124 by 3. Now we just need to take the difference of these two values. Let's just multiply and divide this by 3 for convenience. 42 into 3 is 126 by 3. So by taking the difference, we get 126 by 3 minus 124 by 3. It comes to 2 by 3, which is 0.667. So the correct answer is 0.667. Let's move on to the next question. The deflection y of a certain beam of length L and uniform weight per unit length W is given as y equals W by 48 EI into 2x raised to 4 minus 3lx cube plus L cube x, where x is the distance from the point of support and EI is a constant. The non-dimensional location x by L, where the deflection of the beam is maximum, is. This is a maxima question, and since there are a lot of variables, it makes sense to make some substitution to simplify it. So let us take our answer, the value of x by L, as a new variable. So put x by L equal to u. This means that x is equal to Lu. We are going to substitute this in our expression for y. So we'll get y is equal to W by 48 EI to L raised to 4 not x u raised to 4 minus 3L into L cube u cube plus L square into Lu. We can take L raised to 4 common. This is sorry L cube. We can take L raised to 4 common from all the three terms. We'll get W L raised to 4 by 48 EI into 2u raised to 4 minus 3u cube plus u. This thing over here, let's take it as a constant k, and we'll proceed with the procedure. So let's start by differentiating this expression for y. So let's write it again over here first. Y is equal to k into 2u raised to 4 minus 3u cube plus 4. Differentiating this with respect to u, dy by du is equal to k into 8u cube minus 9u square plus 1. This is u. Then equate this to 0. Since this is a cubic equation, let's try a few values. For u equal to 0, this doesn't work. Since this one will remain. Let's try u is equal to 1 now. For t is equal to 1, we get 8 minus 9 plus 1. So yeah, this is 0. So we're getting 1 root at u equal to 1. So let's perform synthetic division now. We get 8 minus 9, 0 and 1. The one of the roots is 1. So we get 8. 8 minus 9 plus 8 is minus 1. 1 into minus 1 is minus 1. 0 plus minus 1 is minus 1. This comes to minus 1 and this is 0. So we get 8u square minus u minus 1 is equal to 0. So we can find the roots by the quadratic formula. U is equal to minus b plus or minus root of b square minus 4ac divided by 2a. So evaluating this, we get the two values as 0.421 and minus 0.296. We need to use a calculator to get these exact values. So the three values are u equal to 1, u equal to 0.421 and u is equal to minus 0.296. Now we need to find out which of these values actually forms the maxima. So let's take the second derivative. It comes to d square y by du square, which is equal to k into 24 u square minus 18u. At u is equal to 0, that y double dash, it comes to, when we, sorry, not u is equal to 0, u is equal to 1. Y double dash, it comes to this value k into 24 minus 18, which is 6. This is a positive value. Hence, u is equal to 1 does not form a maxima. It forms a minima, to be more specific. Then, at u is equal to 0.421, we need to use a calculator to find this. Y double dash, it comes to a negative value. And at u is equal to minus 0.296, it comes to a positive value. So negative value is over here. This will form a maxima. So at u is equal to 0.421, we get a maxima. Do verify the values coming as negative or positive with a calculator by yourself. So at the value of u is equal to 0.421, we're getting the maxima. And since we started with x by L, the final answer as u, this answer also comes to 0.421. So that's the final answer. Thank you, everyone.